మాస్టర్ మాకు 49 వచ్చినాయి. Good afternoon, students. So only few students are joined. Good afternoon, students. Okay. So see here, now in today class we have to discuss the fifth unit. So in last class we have to complete the fourth unit. Now in today class we have to discuss with that association analysis. So in association analysis, mainly we have to discuss the concepts. What is the association and what are the algorithms you have to use. And mainly here we have to use the a priori algorithm and a quick growth algorithms we have to use. So these algorithms is completely based on the frequent item set. Frequent item sets generation. So this is completely based on that market basket analysis, MBA. MBA means market basket analysis. Which items are frequently we have to purchased by the customers. Based on that, we have to frequent item set we have to generate it by using these algorithms. This type of concept is simply called as association analysis. In the association analysis, we can do with that frequent item set generation with the a priori and quick growth algorithms. So how we can represent what are how the rules are you have to generate it. These all things you have discussed in that association analysis. So here association analysis aims to extract the interesting correlation, frequent patterns, associations, causal structures amongst sets of items of objects in transaction database. So any database, whatever you have database you have to consider, which one the frequent items you will have to purchased by the customers or items purchased by the items from the items for each customer. So here we have to analyze that items or objects in various databases. That is simply called it as association mind. Association rules are widely used in various areas like telecommunication networks, risk management, inventory control, cross marketing, and catalog design and clustering classification. In all these cases, we have to use this association analysis. So see the example. You have to see the example here. Rule from body and head, support and complex. For example, here this is the body you have to represent. What is the relationship between that support and complex you have to represent it? That is the head. So for example, if X is the purchase of the computer, he also buys the computer software. So that is the X is the person who have to buy the computer. He may buy the computer software itself. That is the 40% and 50% you have to represent. That is the rule we have to represent it in association. What are the association rules or basic concepts? Here, first one is in association rule. First, we have to represent the database of transaction. Each transaction is list of items, and find the all rules that correlate the presence of one set of items with that of another set of items. Example: 98% of the people who purchase the rice and auto accessories also get automotive services done. So completely it is based on the market basket analysis. This process analyzes the customer buying habits by finding the associations between the different items that customers place in their shopping baskets. The discovery of such associations are retailers can help the retailers developing the market strategies by gaining the insight into which items are frequently purchased together by the customer. And if any customer, most of the customers will have to visit the a retail shop. So that is a frequent items are purchased by the customers that you have to identify, and you have to represent those items. Which items are frequently purchased? Those all items you have to represent it as one basket. they have easily to pick that most frequent items. So that's that basket you have to pick by the customers. So that's the way you have to improving the business. So that is simply you can say that association applications. So maintenance agreement here we have to in different applications we have to use this market basket analysis like maintenance agreement that is the boost my sales of the information, home electronics, attached mailing and indirect attached mailing in direct marketing. So association rules you have to represent it with the two ways. One is the support and second one is the confidence. What is the support and what is the confidence we have to represent it here? An association rule is an implication expression in the form of x implies to y, where x and y are the disjoint item sets. X intersection y is equal to pi. The strength of the association rule can be measured in terms of its support and confidence. Support determines how often rule is applicable to the given data set, which confidence determines how frequent item sets in y appear in transactions that contain in X. So here the formal definition is of metrics, support and confidence. We can use the support and confidence. Confidence is the other hand. You can say that X implies to Y. That is the rule you have to take it here. And here you have the two major subtasks you have performed in association rule mining algorithms. First one is the frequent item set generation, and second one is the rule generation. So we can do with this frequent item set generation and rule generation. You see this diagram it shows. So here we have the purchasing transactions. A is purchased by that is the frequent item generation you have to perform here. Total items are A, B, C, D, E. One customer you have to purchase it by the A, on B and C, D, E. And one customer you have purchased A, B, AC, AD, AE, BC, BD, BA, CD, CE, BE, ABC, ABD, and which items are frequently they have to purchase. So then only you have to consider, you have to finally you can get them. These are the ABCD you have to get. So this is the frequent item generated algorithms. Mainly you have to use the two algorithms. One is the a priori algorithm, second one is the applicable. A priori algorithm, seminal algorithms proposed by the R. Agrawal and R. Srikant in 1994. Those two people are the Indian people. 1994 mining frequent item sets for the Boolean association group. The name of the algorithm is based on that fact. Algorithm uses the prior knowledge of the frequent item set properties. A priori implies an iterative approach of level-wise search, where k item set used to explore the k plus one item set. First, the set of frequent one item sets is found by the scanning the search database to accumulate the count for each item and collecting those items and that satisfy the minimum supply. The resulting set is denoted by the L1. Next, L1 is used for find L2. Set of frequent two item sets is used to find L3 and so on. The k item sets can be found finding the each LK requires one full scan of the database. So a priori algorithm you have to represent the all non-empty subsets of frequent item sets must be frequent. So generally in a priori algorithm you have to perform the two actions. One is the join step action and the second one is the prune step action. First one is the join step. The candidate k item set is created by the joining L of k with the itself. This set of candidates is denoted by CK, and prune step we have to represent it as prune step is a superset of LK, may or may not be frequent. The all item gets included and determine the count of each kind. So see here, this I want to explain along with the example using a priori algorithm. For example, here you have to consider the transactions. That is the transaction of 100. So total 9 transactions we have to consider here. First transaction they have to purchase the items I1, I2, I5. Second transaction I2, I2. Like this is the transaction. The item IDs they have to purchase it by each customer. First customer, that is the represented transaction 100. Like that, 9 transactions you have to consider. Which items are frequent items? So first one, we have to represent the I1 purchased by the how many customers? See here, I1 is purchased 1, 2, 3, 4, 5, 6. 6 people are purchased by the customer. So here you have to consider that is the 6 people. That is supplementary. Next, I2 is purchased by the how many customers? So I2 is purchased by 1, 2, 3, 4, 5, 6, 7. 7 people are purchased by the I2. Like this way, you have I3 is 6, I4 is 2, I5 is 2. Check all its supplementary counts. Now you have to compare which one with the supplement count, the support count, that is supplement not its support count with the minimum support count. Minimum support count is 2. So like we have to eliminate the 2. That is I4 and I5 you have to eliminate it. Now you have to consider that is the minimum support count 6, 7, 6, 2, 2. Now we have to generate the C2 candidates for L1, I1 and I2, I1 and I3, I1 and I4. So now we have to generate the number of list of items. Now we have to consider I1 and I2. So how many times you have to getting and I1, I2 purchased by the customers. So I1, I2. Here we have the one first one. Here 2. Here 3. Here total 4 times I1 and I2 purchased by the customers. So I1 and I2 we have to purchase by the support count is 4. Similar way I1 and I3. So we have to find out I1 and I3. So here I1 and I3, I1 and I3, I1 and I3, I1 and I3. So totally 4 times. So here we have to represent it as 2 times they have to purchase by the I1 and I3. This is the support counts you have to represent like this I1 and I2. So you can get the support counts like this. So which items are most frequent items you have to consider? So that is the I1 and I2 4, I1 and I3 4, and you have to eliminate the minimum support counts. That is the I1 and I4 you have to eliminate it. I1 and I5 is 2, I2 and I3 4, I2 and I4 2, and I2 and I5 is 2. So remaining are minimum support counts, that is 0 and 1. We have to those are we have to. Now you have to consider I1, I2, I3. So now you have to item set you have to represent it I1, I2, I3. So next item set you have to represent it as I1, I2, I3, and I2, I1, I2, I5. See here I1, I2, I3, I1, I2, I3. So I1, I2, I3. So here purchase by 2 times. Similar way, we have to consider another one that is the I1, I2, I5. I1, I2, I2. I1, I2, I5 is the one. I1, I2, I5. This is the you have to consider here. So you can support count is 2. Now we have to compare the candidate support count. Minimum support count, we don't have any minimum. These are the minimum. Now we have to consider that is the I1, I2. These are the values. I1, I2, I1, I1, I2, I3, I1, I2, I5. So these are the final values. These are the frequent item sets generation using a priori algorithm. So here most frequent item sets are I1, I2, I3, I1, I2, I5. Okay, now we have to these item sets only we have to represent it as one basket. Most of the people they have to pick those baskets like that. That is the using a priori algorithm. Yeah, this is regarding to this one. Next one, applicable algorithm. So FP growth is the finding the frequent item sets without candidate generation. We re-examine the mining of the transaction database in frequent pattern growth. See these transactions, total 9 transactions you have to consider, and you have to represent the values. I2, how many times? I1, how many times? I3, 6. So this is the item ID and its support counts. So I2 is the 7 times you have to represent it. I2, 7. So now you have to connect it with that along with the node links, and we have to represent the null value. That is the I2 is 7, and I2 you have to connect it with that I1. So I2 is 7, I1 is 6. So I1 is 6, how many you have to get it? So I1 is 4. So I1 is 2. So these two you have to add it, you get the I1 as 6. Similar way I3 is 6. So I3 is 6, you have to represent it as this is the 2, this is the 2, this is the 2. Total 6 you have to represent the support. And similar way I4 is you have to represent it as I4 is 1, and here also you have the 1. So 1 plus 1 you have to get in the support count 2. Similar way I5 is 1 and I5 is 1, your support count is 2. So like this way you have to represent the account. First item ID and its support count you have to retain, and you have to represent the node links. So finally you can represent the algorithm what is the conditional pattern basis. This is the conditional F3 you have to generate it, and the frequent patterns you have to generate using FP growth. So confidence you have to find out here you can apply the conditional property support of count A union B by support count. That is the way you have to find out the confidence in FP growth, and it confidence 50%, 100%. You have to represent it. Okay. These are the two algorithms you have to use in association analysis.